All right, we're back. We are on page 3 of notes 24 in Calc AB. We're solving differential equations. On this particular page, we're finding what are called particular solutions. And that just means solve for C. So if you solve a differential equation, you'll get a general solution that has a plus C in it somewhere, or just a C in general. It's usually a coefficient, in fact. In this case, we're going to actually be able to solve for C. So same deal as last time. I did not space this out well, so I'm going to solve the differential equation on the left and then try to go from there. So let's start with the differential equation, right? So it's originally written as dB dt equals 3 minus b. I do not like to solve it when it looks like this. What I'm going to do is I'm going to factor a negative out of everything on the right. So dB dt is negative, I'll say -1 times b minus 3. Now I'm going to separate. If you do that step, you will make far fewer mistakes. If you don't do that, you might make a mistake on the left-hand side with a u substitution. You need to pick up a negative. It makes everything a little more complicated. I definitely recommend leading coefficient of b be positive. Try to make that happen, which you can always do by factoring. So I would say always do it, but it's up to you. dB over b minus 3 is going to be negative dt, which means the natural log of the absolute value of b minus 3, I don't know if that's parentheses or what, is going to be negative t, and then plus c goes with our independent variable, which is t in this case, which means that b minus 3 is equal to c e to the negative t. So that's where we skip a bunch of steps. And then I'm going to actually solve for b. Say b is 3 plus c e to the negative t. All right, so that is my general solution. So if the problem just said solve the differential equation, this is the solution that I would get. Now to find a particular solution, you need an initial condition. So my first initial condition is this, that b of 1 is equal to 1. So let's do part A. So A, I'm going to get 1 equals 3 plus ce to the negative first. Okay, so negative 2 is equal to ce to the negative first. C is equal to, I'm going to say, well, it's negative 2 divided by e to the negative first. 1 over e to the negative first is just actually e, so I'm going to write negative 2e. So negative 2e to the first, which is equivalent to negative 2 divided by e to the negative first. You can like work it out, hopefully. So then I will say that my solution is 3 minus 2e times e to the negative t. So finally, I would get 3 minus 2e to the, should I write 1 minus t or negative t plus 1? I don't really know. I'm going to go with negative t plus 1, I guess. I don't have a preference either way on that, turns out. As I was writing it, I was like, I don't really care. Sometimes I do have a strong preference, not in this case. All right, so that's our particular solution when b of 1 equals 1. The next one, b of 1 equals 3. Well, if you did the last problem, you might be suspicious of this one because the differential equation is dB dt equals 3 minus b. If b is equal to 3 and dB dt is 3 minus b, then dB dt is just 0, which is a horizontal line. So I'm expecting this answer to actually just be b equals 3. If I get that, I will not be surprised. And I think I'm going to get that. So let's do our substitution. So we get b equals, nope, not b. What? We get 3 equals, go away. Okay. 3 equals 3 plus ce to the negative first. So you do get 0 equals e to the ce to the negative first. Where's my brain? There we go. Ce to the negative first. So c is equal to 0. If c equals 0, we get b equals 3 plus 0 e to the negative t, or b equals 3, which is exactly what I was expecting because I was kind of thinking ahead. But it takes a long time before you like have the brain power available to think ahead when you're doing these things. And there's nothing wrong with that. It just takes a lot of practice and a lot of thinking, and just experience. Like you see these things and you sort of like know ahead of time what's going to happen. And it makes it look a lot easier than it actually is. So don't get discouraged when you're like, how did anyone know to do that? Like, they knew to do it because they've done it before, basically. No one here is inventing calculus. We're standing very much on the shoulders of giants. All right, let's do this. So 5 minus 3 equals CE to the negative first. 2 equals CE to the negative first. So I get 2 divided by e to the negative first, which is just 2e. 2e. So I'll have b equals 3 plus 2e times e to the negative t, which is the same as b equals 3 plus 2e to the 1. Well, I'll go with negative t plus 1 again, just for consistency with that first answer that we got. So I kind of color code them. You can see like the given initial condition and its corresponding particular solution. So particular solutions don't have C's in them. You've solved for C. General solution, though, the one that's kind of in a grayish color, that one is a general solution because it still has a C in it. I'm going to go ahead and solve this one. And then maybe what I'll do is, I guess, check them on the calculator at the very end. You should always check as you go, but what are you going to do? Once again, spaced terribly. So I'm just going to do it over here on the side. So dr over dh equals h plus 4 over r. All right, this one looks doable. So we do this. So I like to put parentheses, h plus 4 dh, to remind myself that that dh goes with everything that's on the right-hand side. And then integral. So here we're going to get 1/2 r squared is equal to 1/2 h squared plus 4h plus c. So there are some people who will integrate, where do I have space? Like almost nowhere, but maybe I have space down here. There are some people who will integrate the quantity h plus 4 dh as 1/2 the quantity h plus 4 squared plus c. They're not wrong. They're just kind of doing it in a slightly different way. And it's probably easier to evaluate that thing when it's written that way, but it's just never how I think to do it. So the next thing I'm gonna do is multiply through by 2. R squared is h squared plus 8h plus a new value of c. So it's not the same c, but we just call it c again. So now we're gonna have r is equal to plus or minus. So this is weird because plus or minus is not a function, but this is what I'm going to start with as my general solution. So I have plus or minus, which is not a function, so it can't really be. So the choice of plus or minus is going to be based on the initial condition. So what do I mean by that? Well, let's look at our initial conditions. So here, r of 2 is equal to -5. So I'm going to say, so I'm going to make a note here. Since r of 2 is less than 0, we're going to pick the negative square root. Because if we don't pick the negative square root, we're never going to get a negative value out of it. So we have to pick the negative. So what I'm thinking here is I'm going to say -5 equals negative square root of whatever, 4 plus 16 plus c. All right, so I can divide by a negative, I can square both sides, get 25 equals 20 plus c. So c would be 5 in this case. So my particular solution is going to be, so I'll say therefore, r equals the negative square root. And also it's a little weird, right? The c ended up inside of a square root. Like, it happens. All kind of like all bets are off about where c is going to end up when you do this kind of process. Plus 8h and then plus 5. So this, I think, is going to be our solution, unless we made a mistake. We'll find out when we go to check it. All right, now for this one, I noticed that since r of 2 is greater than 0, I better pick the positive square root. Otherwise, it's not possible to go through this initial condition. And we need to go through the initial condition. So we're going to end up picking So you have to make a choice, and it's kind of weird. Positive square root. And then we're not going to write the positive, but that's what we have to pick. So let's see what happens. So I'm going to say 6 is equal to the positive square root of h squared, not h, because I'm replacing h with 2. So it's 4 plus 16 plus c. So I can square both sides, get 36 equals 20 plus c. So I'm going to get c is 16. And that means, so you have to remember that you pick the positive square root. So r is going to be the positive square root of h squared plus 8h plus 16. So it's actually going to be kind of hard to get the calculator to give us these answers, I think, because the calculator isn't really programmed to care about the fact that the solution should be a function. So we'll see. Let's go to the calculator, and we're just going to check these kind of quickly. So, I mean, you should have them written in front of you. So the fact that we're just going to see the calculator, hopefully it doesn't mess anything up. I'm going to go new calculator. I'll just type it in, DE solve. And then it crashed again. Oh, and it's back. Okay, so, oh man, I'm not sure if I want to keep going because the calculator keeps crashing my videos and it's really annoying. And B, I mean, I'm gonna keep going, but there's a chance that this video will not end nicely. And if that's the case, I apologize, but I'm not doing it again. So we'll see. 3 minus 2, got that, nice. And then when we said this, we got that. And then when we said this, we got that, all right. And then let me change this up. And then you could probably hear the desperation in my voice when it started to crash. That it's just so annoying. You know, you put like a lot of effort into this, and then at the end, it's just like, oh, did you want me to not crash? Like I was hoping you would have considered not crashing. This, and then my independent variable here is going to be h, and my dependent variable is r. So a lot going on there. I'm gonna press enter. Okay, so I can I just square root? I get this. Ooh, that's really interesting. And then because my initial condition is negative, I have to choose the negative, but I think it confirms. So like this is basically saying r equals the negative square root of h squared plus 8h plus 5. It's really inconvenient that the calculator doesn't respect the fact that the solution must be a function. But like there's more complicated things when it comes to differential equations. So like I get it, but for our purposes, we must get a function. So let's see, this gives me this. And so basically I can confirm that C is definitely 16. I have to think about it. What if I do like such that R is greater than 0? Can I make it give me the answer? Holy cow, I cannot. I don't even know what's happening there. Oh, it like factored. Oh man, crazy. What if I take out that part and I just do this? Ooh, really interesting. So the calculator noticed that h squared plus 8h plus 16 is a perfect square. It's actually the quantity h plus 4 squared. This is really interesting. I did not see that as a human. And then, so the square root of a perfect square is the absolute value of that thing. That's really cool. But anyway, I'm just going to use this to say that, yeah, so C was definitely 16 for that problem. That's what I'm going to say is kind of like what's going on there. So let's go back to the notes. You can see we got all of them. So I'm going to stop this video here, come back in the next video and do a little bit more. So I'll see you there.